Good morning, 9ENF. So, welcome to those of you just showing up. This is 9ENF. We're doing physics, we're doing lenses, we're doing eye physics today. And if you missed the video, then hopefully you're going to take notes on this and then email me and let me know that you saw the video. But here we are, and I've got people joining me. So let me know when you're here. Go ahead and say hello, and I'll give you some participation points. Oh, super. Leia's here. Tony's here. Dominic's here. And Lena's here. Oh, you guys are so quick, man. Okay, Natalie's here. Leah's here. Lucy's here. Hello. And I've got Magdalena, Muriel, and Malek. Okay, Magdalena, Muriel, Malek. Good. I've got, oh, you guys are so quick. Shilpa, Larissa, and Christian. I've got Santiago, Ali, and Nicholas. Dynamite. Who else I got? I got Julian L. I got Kira. I've got Felina and Sarah and Tom. I've got Vincent. Hello. And Merla. Hello. All right. Whew, I can stop panicking a little bit. Now I can catch up with you. Good. Any others that are joining us, let me know and say hi. Today, what we're going to do is we're going to finish doing an array diagram to help locate an image as we started doing last time. And we're going to talk about eye physics. I brought an eye with me, not just my own, but another eye. And then, yeah, see how that goes and see how the eye works and see what problems we have with our eyes as well. Got a couple others first, though. I got Jason and Benedict. Very good. Any others joining me, please say hi. But I've got a bunch of you so far, which is great. I'm glad you could join me. I got my two whiteboards ready today. And we'll continue with optics in just a moment. What do we got? I'll give about one more minute and then we'll start up. There's Micah. Any others? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 of you there, dynamite. And that's what I got, 26. Good, I think I'm going to set this aside. I'll just check people in as they arrive if they're a little late. Let's move the markers where I can get to them. And let's start up. Okay, you ready? Here we go. So we're still studying optics. We're still studying lenses. And there's Philip. Hello, Philip. And what we didn't do, I used a lens last time and we kind of measured it. So there's 3 ways to get an image. What are they? What are they? You tell me. Make it your job. So type in. I got a bunch of you now. What are 3 ways to get an image? and to be able to estimate where it is or figure out where it is from the lens. So there's 3 ways. Give me those. Bump, bump, bump. At least 2 of them we've done. Using the formula, great. Physically measure, Sarah, good. There, hot on the stick, good. So we physically measured. We did that over on the desk there. We used the formula, and a lot of you got the lens formula, it's called. Super, great. So we did that last time. And I guess we haven't done the 3rd way. So we're going to do the third way. Let's try that again. We're going to do the 3rd way today. Anybody else see it? We didn't do the 3rd. Thank you, Santiago. Good. So let's do it now. Okay, so 3rd way. To find an image. We're going to do what's called a lens diagram. Now, alas, my whiteboard does not have squares. If you have squared paper, do this. I see you there, Tom. Thank you. O'Reilly's trying to join but has issues. Thank you, Tom, for telling me. Okay, that's fine. Okay, so if you have some squared paper, use that. Okay, I don't. So I'm going to try and tell you how to do it with your squared paper. And all I've got is an unsquared whiteboard. That's life in the new era, right? Okay, here we go. So we're going to draw a long line. Ready? I'm going to make it as straight as I can. You know me, I'm kind of a slob. I'm doing the best I can. You can make a line about on your paper about yay long, okay? On your squared paper. That's called the optical axis. See if you can see that. Yeah, that's called the optical axis, right? Like an X or Y axis. Then you're going to draw the lens. And if I was you, I would draw your lens about 4 boxes high and 4 boxes low. Ah, Priya's here. Thank you, Priya. Now, I can't draw 4 boxes because I don't have boxes, but I'm going to just draw it here, okay? So here we go. Here's my lens. I'm going to draw a convex lens, also called a converging lens. So here we go. So draw it so it's fairly symmetrical in your diagram. Again, you go 4 boxes up, 4 boxes down. And then I'm going to put the F. Okay, so I'm going to put the F. Oh man, let's also put it about 4 boxes over. So there's my F. And remember, if I turn my lens around, where's my flipping lens? Hold on. I've got it on my table, also known as a box. And there's my lens. Okay, so we might have talked about this before, but if it's symmetric, I can turn the lens around and I still get the same thing each way. It doesn't matter, okay? So what that means, there's an F on both sides, okay? So if I got an F that far here, I got an F exactly the same distance over here. So please draw both focal points, okay? Good. Anybody else joined? If so, say hi so I know you're there. Then I'm going to put an image. I'm going to make my image green because I like green. And I'm going to put my image where? I'm going to put my image here. All right, where is that? Okay, so for you guys, let's just say I did, Malon's here. Hi, Malon. For you guys, let's say that if this is 4 boxes high and that's 4 boxes over, let's make this maybe 2 or 3 boxes over. and make your height of your object just, you know, a couple of boxes. Don't make it super high. Otherwise, it doesn't work so well. Okay, here's what we're going to do. We're going to take 3 rays of light. I know there's lots and lots of rays. We're going to take 3 and prove and show where that image would be on the other side. And I'm going to do all 3 rays in a different color. Okay? Now, I don't even have a straight edge. That's how terrible this is. Can I look around the room? Is there anything I can use for a straight edge? Flipping A. All right. I've got part of a ruler, but it's not very big. Okay, here we go. All right. Got my ruler. Let's do the first one in red. Okay. Okay, so there's 3 useful rays to help you find the image on the other side. So here's the first one. We're going to take from the top of this is our object. Okay, that green thing is our object. So the arrow is our object. Okay, so we're going to go through the middle of the lens. You ready? So from the top of your object to the middle of the lens. And by the middle, I mean right here, okay? Boom. Right that spot. So go through there and then keep on going. Your results, by the way, are going to be way better than mine because you've got squared paper. So I'm a little envious. Even my straight edge isn't that straight. Look at that, man. I hope you got better equipment than I do. Okay, now I'm going to extend this sucker a little more. And that's 1 ray, okay? I'll put a little arrow on it, just like in math class, a ray, right? So that ray 1, boop, here, I'm going to say 3 useful rays. Now, you might have done this in the assignment I gave you weeks ago. Three useful ways. The first ray is the one we just did, and that's the one that goes straight through the center of lens. Why are we writing this? Because you can use the same 3 rays to do lots of other stuff. Yeah, exactly. Diagonal, exactly, like up from the top of your object, straight through the middle of the lens, and then just keep on going. Let's change colors. I'm going to do the next one in blue. Okay, so that's going to be useful ray number 2. Useful ray number 2, here, and let me tip this a little bit so you can see that's 1 so far. Okay, 1 is fairly simple, right? Shaboom, diagonal through. Okay, everybody got that? Okay, so here's 2. 2 is going to go from, this is going to take a little explaining, all right? To middle of lens, straight. I can't even spell straight here today. Better get my through middle of lens straight, whoop, up to here, okay? Then through the F on the opposite side. All right, so I wrote here, to the middle of the lens, so straight, then through the opposite F, the opposite focal point. You ready? Like I said, yours is going to come out better than mine, all right? Oh man, both sides are not the best straight edge. Okay, so here we go. All right, so go to your middle of your lens. All right, so go that far first to the middle, and then go through the F on the other side. And go until it hits the other line, okay? All right, they should cross. All right, they should cross. So there's 2. The red one was 1. And now we're going to do 3. Okay, I see a couple others there. And yeah, it's Noah. Noah Berry. Okay, thanks, Noah. I just wrote Noah down. Okay, so let's see what we got. How about green? Can we do green again? For the green ray, here's the third one. We go through the near focal point to the middle of lens. Through near F, I'll put F for focal point, to middle of lens. Then parallel out the other side. So we say then parallel to that line, which is called the optical axis. Okay, so let me read that again, then we're going to do it. And Riley's here. Hi, glad you could make it, Riley. Good. Exactly. Okay, so through the near F, so we're going to go to the middle of the lens, and then we're going to go parallel to the optical axis out the other side. All right. Again, your results may come out better than me because you got lined paper and you're home and you got probably a better straight edge than this dumb thing. Okay, so there's my F. There we go. All right, there's to the middle of the lens, okay? See if you can see that. So there it is. Goes through F and then to the middle of the lens. And now we're going to go parallel out the other side, okay? I'll tip it again in a second. And mine do not meet very well. I really got to kind of cheat. If you did it right, all 3 of them should meet. But look at my work. It is not all that hot. So I got to make my dot really big. So I'm not really happy about that, okay? But what am I going to do, right? Doing the best I can in a basement room here. Okay, here we go. So there's my image. So, okay, it's kind of right here. Big dot. It should be where all 3 of your rays meet, okay? Don't look too awful. Okay, but check it out what's going on. Oh, it's upside down. So I get an arrow on the other side. But it's upside down. Do you remember how we did this with our object last week? Our object was a flame, and the flame was also upside down last week. Okay, so this is my object, this is my image. Okay, so you ready? Now we got some questions for you. Let's get you involved because I got a lot of you. I got 30 of you. Can you describe for me the image compared to the object? The image is what? There's more than one description word. There's three. Formal physics words for this arrow. It's inverted. Thank you, Tony and Marla, and lots of you got it. Good. So it's inverted. Fancy word for upside down. And oh, nice. I've got all three words. And so I got from Shilpa and from Santiago, it's real. Real means I could actually focus it on a screen like we did last week. God, you guys are so fast. I can't even see the first person anymore. Man, thank you for your participation. That's super. So it's inverted, it's real. And then I got this from a couple of you, including Nicholas. And let's see who else got there. Larissa got there. And they said it's magnified. Ah, because it's bigger than the other arrow. Beautiful. Nice. That, let me tilt it again because that gets some of the glare off it. That is how to do a ray diagram, okay? What did I call it? I called it a lens diagram. Bad teacher. Can you change the word lens to ray? Ray diagram. Congratulations. You might have done a couple of these in the reading assignment as well. At any rate, hope it went well for you. Hope it went even better than mine, although mine is not too bad for not having lines. I'm happy. Questions before we start to talk about our eyes. We're going to do eye physics in just a second. Any questions? I'm going to change whiteboards. I bought a second one. How many of your teachers got two whiteboards, huh? Deluxe basement here. Okay, then I'm going to change that. We done there? Can I move it? Ah, Ben is here. Good. Thanks, Ben. Ben, you may have to get some notes for the first part there. Mr. Deputy. Okay, Oliver, are we going to talk about spherical lenses? Not as such, Oliver. I know you can have like a witch might have like a sphere of glass, of solid glass. And it is interesting. It gives some virtual images. You can't touch it, but you can see like an upside down image in the glass if you've ever seen one. Ali, do you have one at home by chance? Maybe you're asking about it because you got a crystal ball at home. And while he's thinking about that, I'm going to get the eye. Okay. Okay, Ray, Leah has a question too. How would the rays look if the image would be not real? How would that change the image? If it's not real, what you got to do is, and this is in your textbook, you got to, they kind of go like this, Ray. They go, they don't cross. And what you got to do is you got to make them go backwards like this. It's weird. I don't need you to worry about it, but in case you ever are there, then that's how you do it. Alyssa's here, but she can't find the type in her comments. Good. Okay, so I got Alyssa and I got Cosmas here. Welcome. Such glad participation. Glad you're all here. Anything else? Yeah, and that's fine, Ali. I'm glad you're interested in it. Yeah, check it out on the internet. Okay, you remember that old fairy tale, Grandma? What big eyes you have? Well, I brought a really big eye. Okay, all right. What am I doing now? What am I doing? I'm keeping an eye on you. All right, I'll shut up. Okay, so here we go. We're gonna like slowly draw this eye. We're gonna do eye physics now for today and probably some of next week because we won't be able to finish it. So we're gonna diagram your eye and also figure out what some eye problems are and how they can be solved. Okay, so you're gonna get some biology with your physics here the next week or so. Yeah. Okay, here we go. Uh, okay, I'm gonna draw a pretty big eye. If you got a paper, maybe draw your eye in your paper like this big. Okay, you want it big enough. My jokes are funny. Boy, I appreciate that, Leah. I'm the only one laughing in this room, let me tell you. Okay, here we go. So, um, I'll try and do it maybe where it's not so blurry or not so shiny. How about over here? Yeah. Okay. All right. You can just kind of draw with me, all right? Now that's got to be bigger. Sorry about that. Let's move it over a little more. Yeah, that's the way I want it. Okay, so now I gotta do the other one. That's not too bad. Okay, so see if you can make something like that, okay? Get as close as you can. Um, Marino, you're in the wrong class. This is 9EF. So you're in the wrong physics class because you're in 7th grade. Now you can watch if you want. No big deal to me. Okay, so let's take this thing apart. All right, so what we got in the back is this thing, okay? See that? There's the front of your eye. There's the back of your eye. You got two eyes, by the way. And in the back of that, where's that going? Maybe somebody, what is it and where's it going? And we'll label it together. Okay? What is this thing in back of the eye and where's it going? While you're thinking, let me get a magic marker. We're going to label that. It's going to the brain. Yes, it is. Good. And Tom's got the name. It's the optical nerve. So optical nerve to brain. Right, so this is the optical nerve. Yeah, good. Okay, We're going to take our eye apart now, okay? At least this one. So here we go. Oh, yeah. Ay, caramba. Okay, so there's half of the eye. A lot of this looks like it's something, but it's actually mostly just empty space filled with fluid, but that's about it. Okay, and then the back. See the back of the eye? That's where the image is going to land. Okay, the back of the eye back here. Have you ever taken a picture and you look and the eyes look red? Okay, well, the eyes look red because you're looking through the person's eye to the very back part here. And let's write that in. I should have done that in red. I think I will do it in red. It's sort of like the screen. So where the picture lands back here, that's the image where that lands back here. What is that called? Does somebody know for fun? Starts with an R. So it's all the way back here. It's where the image lands back here, okay? Starts with an R. And Tom knows. Tom, how do you know all this stuff? That's cool. So did Jason and Ali. Well done, folks. So it's called the retina. So that's all this, okay? This is all the retina. All that. So the retina is where the image lands. That's supposed to be an H. Retina, so that's where the image lands. It's like a screen, so to speak, okay? Yeah, retina. Yeah, just like it sounds. Maybe I'm getting ahead of myself because I want to put in some other stuff that's pretty cool. Let's put in the lens, okay? Look at my little thing here. So the lens fits in here in your eye, and we're going to see where it fits in my drawing now too, okay? All right, let's put my little eye apart here. Hey, caramba. Okay. I'll show you some more parts of that eye in a second. Let's put in the lens. The lens fits in here. The lens. You can probably tell by its shape, the lens is a lens. A lens. So what sort of lens is that just by the shape? Concave would be the opposite. So not concave. Convex, good. And then I need another con. So it's a convex shape, and we call it, several of you got it. Sarah's got it. Santiago, Ollie's got it. And yes, good. Muriel's got it. So it's a converging lens. And essentially, I'm going to change boards for a second. Look at this. Remember how our image here with the converging lens was inverted? Well, here's the wacky thing, guys. Everything you see is upside down. When the image comes back, it lands on the retina, and all of the images your brain sees are upside down. And your brain is used to that. So it's okay. That's strange. Now, I read that they did something really bizarre with somebody once. They put another lens in front of their eye that flipped the image upside down. And when they flipped the image upside down, it actually landed right side up on the guy's retina. And first it was bothering him, but after like about 20 minutes, the brain adjusted. And then for him, it seemed like it was right side up when it was right side up. Is that weird? But for you and I, pretty much everything we see is upside down. You're looking out at somebody, they're upside down. You're looking at a candle, it's upside down. That's the image you see, but your brain flips it up so you see it in your head and your thoughts in your brain as right side up. Exactly, Ben. They got used to it. Yeah. Isn't that bizarre? Crazy. Okay, so, but that's because we got a converging lens. That's what they do. They flip the image around, okay, as we've learned. Okay, let's talk about this part. What is that? Can you guess what that is? That part here and here that I put in little greenish part. What is that? It's what's holding the lens. So it holds the lens and does something else. It's the, wow, Tom, you know all the stuff. It is, it's the iris. So I made this person's eyes green. Your iris might be brown or blue, sometimes a little yellowish. On my cat, it was a little yellowish. Okay, but that's the iris, right? Oh, let's see if you can see that. Yeah, so I wrote here iris, it holds the lens and blah, blah, blah. Okay, now, it doesn't just, whoa, speaking of holding, stay there. I erased my word, iris. Okay, it's a muscle. So I'm going to write it's a muscle that holds the lens and it does something to it. Let's see if Tom knows, because he seems to know a lot about the eye, or somebody else. What does that iris do to your lens? It doesn't just hold it. And this is where it gets really cool. What does it do to the lens? It focuses the light. Yes, Tom, by doing what? Okay, so everybody do this with me, okay? It concentrates the light. I'm getting some answers now. Hold on. Changes the size. Felina's got it. Yeah. Okay, so well done, Felina. So muscle that holds the lens and changes the, let's not just call it the size, Felina. Let's call it the shape of the lens. Whoa, that is bizarre. Okay, so it does make your pupils smaller. Yeah, very good. Okay, another things it does is it controls the empty part here. Malek, you're one step ahead of me, Malek. The empty part here that looks kind of black, that's the pupil. It's this hole. So a pupil, other than being a student, don't take it personally, a pupil is nothing. It's just a hole to the lens. So there's the pupil. Okay, so here's what the iris does. Okay, the iris, I can't do it with this. This is made of glass. Your lens is actually squeezable. I can go like this, squeeze, or I can have it pull out and then it expands. How are we doing on time? We still got a couple more minutes. Okay, do this with me. So you're looking at your computer screen. I want you to look up and look at something further away and then look back at your screen. And for you, it might take like a fraction of a moment for your eye to adjust. For me, because I'm older, it takes a fraction of a moment longer. And what's happening is when I look further away, your iris squeezes your lens into a different shape. When I look close, like at my hand, maybe you should do that. Look at your hand, then look far away. Hand, far away. You should feel your eye change just a little bit. That's the lens changing shape. We're not going to have time today to talk about how the shape changes. We're going to do that next time. But let's finish diagramming the eye, okay, before I get carried away. Okay, so we got the iris, we got the lens, we got the retina, we got a covering on your eye as well. It's a really thin covering. So thin you can see through it. What's that thin covering of your eye? So it's a thin, it protects you. It's a protective covering. All right, so let's see who knows. So on this model, I'll show it to you. On this model, it's this little plastic thing. See that? So that's essentially what you've got. That's what you're looking through, two of them right now. Let's see, some of you got it already. Good. Shilpa, that may be the scientific name. I don't know it. Lucy is here. Lucy Friese is here. Okay, but a couple have gotten the name. The one I know, Kira's got it, Nicholas got it, Tony's got it, Ollie's got it. It's the cornea. So I'm glad you guys know that. That's cool. Cornea, just like it sounds. Can you see that? Yeah, I think you can. So the light comes through the cornea easily, comes through the pupil, right? The empty space here, hits the lens, and then the rays of light go through and land here at the back of the lens. Now, normally I can do this, but it's going to be hard. You may have to try this on your own. If I look, if the image lands right here where these two parts of the retina join to make the optic nerve, right there, that's called your blind spot. And if the image lands there, you can't really see it. You may want to read about that. That's pretty cool. Blind spot. But here's the good thing. It's different for your two eyes. So you always got one eye covering your blind spot. That's why they say driving. If you're driving, there's a driver's blind spot. There really is. Luckily, they got two eyes. If you only got one eye like my dad did, that was bad because you're in a blind spot for him and he couldn't see squat at that moment where something was in his blind spot. But ordinarily, you and I can because our eyes fill in. Good. We're going to do more of what our iris does next time. We're going to do eye problems. We're going to talk about eyeglasses and contact lenses when I see you next week. Thanks, everybody, so much for participating. I hope to see you again in real life soon. Bye-bye.